Okay, so let's get started. Given the polynomial f of x is equal to x to the fourth minus x cubed minus 5x squared minus x minus 6, so we have to find the possible rational roots. So to find the roots, we have to factor this polynomial out. So to factor it out, I think the best method is grouping because it's easy to do in a case we have a higher degree. So let's get started with the grouping. So to group, first you have to expand one of these terms. So I'm going to expand the term negative 5x squared. So let's write it out. X to the fourth minus x to the third minus 6x squared plus x squared minus x minus 6. So negative 6x squared and x squared, when I add them up, it gives me negative 5x squared. So this is still the same polynomial. Now to group them up, I'm going to group these three terms right here, and then I'm going to group these three terms right here. Now I'm going to take out the greatest common factor from both of these groups. So from the first group, the greatest common factor is x squared. I take out x squared and I get x squared minus x minus 6. And now we can factor out nothing from here, so we can just write it's a 1 in front of the, because anything multiplied by 1 is just itself. So x squared minus x minus 6. So now we have our first root, which will be x squared plus 1, and our second not root, but our second let's just say our second let's just call it our second quadratic equation, I guess. So x squared minus x minus 6, because this term right here and this term right here match up. So now we have that. Now this can't be factored further, but this term right here can. So we can factor this into, let's do it by grouping again. Let's do x squared minus 3x plus 2x minus 6, because negative 3 times 2 is negative 6, and negative 3 times negative 2 is negative 6, and negative 3x and 2x add up to a negative x. So now we take out the greatest common factor. These are our two groups. So to take out the greatest common factor from this term right here, we get an x, and then we get x minus 3. And the greatest common factor from the second group will be plus 2, and we get x minus 3. So now we have it all factored out. Let's make it look pretty. Our factors are x squared plus 1, because we cannot forget that we had 1 right here. And now our other factors are x minus 3, x plus 2. Now when you multiply all of these together, you will get back to x to the fourth minus x to the third, so this polynomial right here. Now that we have all our roots, let's see, it's asking for the possible rational roots. So our rational roots are anything which are not imaginary, so they will be x is equal to 3, because it's equal to 0, and we set anything equal to 0, it's the sign flips, because x minus 3 is equal to 0, so x is equal to 3, and then x is also equal to negative 2. These are our rational roots. So use synthetic division to determine rational roots. So to do that, first we're going to have to use this rational root and divide this by our roots. So to do that, we're going to do 3 right here, and then we're going to take the leading coefficients and put them in descending order by the degree. So 1, then we have a negative 1, then we have a negative 5, then we have a negative 1 again, and then we have a negative 6. Now, if this is actually a root of this function right here, the remainder after I divide will be a 0. So to do synthetic division, we first pulled out the first term and we get a 1 right here. They multiplied this term right here by this term right here, so we get a 3. Then we add these two up and we get a 2. 2 times 3 is 6. Negative 5 plus 6 is 1. 1 times 3 is 3. And 3 minus 1 is 2. So we get a 6 right here, and our remainder comes out to be 0. So x minus 3 is a factor, and x is equal to 3 is a root of this function right here. Now, to figure out if x is equal to negative 2 as a root, we just divide, use synthetic division on the new polynomial we get, which is x to the third, because x to the third plus 2x squared plus x plus 2. So to do that, we just put a 2 right there, pull down the 1, and we get 2. 2 times 2 is a 4. Then we get 6, 12. Okay, so it's a negative 2. That's where I went wrong. Okay. So since it's a negative 2, we pull down the 1, we get 1, then we multiply this by here, we get a negative 2, we get 0. We multiply 0 by negative 2, we get a 0. 1 plus 0 is 1. Multiply that, we get a negative 2. Negative 2 plus 2 is 0 again. So we have proven that both of these are roots of this function right here. Roots. Okay, now determine imaginary or irrational roots. Oh, sorry about that. Okay. So our imaginary root in this polynomial is x squared plus 1. Now to determine that, we cannot use synthetic division. So we're going to use long division. So long division is like this. And then we divide the whole polynomial right here by this term right here. So this is our divisor, and where I'm going to write my dividend. X to the fourth minus x to the third minus 5x squared minus x minus 6. Now that we have that, we just divide. So we take this term right here, this first term, and we figure out what multiplied by this will give us x to the fourth. So that will be x squared. So I put it right here above the x squared right here. So we get x to the fourth, but we always flip signs, so we get a negative x to the fourth. And then we multiply 1 by x squared, so we get a positive x squared, but we flip signs, so we get a negative x squared. Now we add, and this cancels out. We get a negative x to the third minus 6x squared minus x minus 6. Now, what multiplied by x squared will give us negative x to the third? Well, that will be negative x. Now, when we multiply by negative x, we get a negative x to the third, but we always flip signs, so we get x to the third. And then multiplied by x, when we multiply 1 by a negative x, we get a negative x, but we always flip signs, so we get a positive x. Now this cancels out, and this cancels out when we add, so we are left with negative 6x squared minus 6. Now what multiplied by x squared will give us negative 6x squared? That'll be negative 6. So once we multiply this by negative 6, that'll give us a negative 6x squared, but we always flip signs, so we get a 6x squared positive. Now 1 multiplied by a negative 6 is a negative 6, but we always flip signs, so we get a positive 6. All of this cancels out, remainder of 0. So we had to get a remainder of 0 in order to prove that x squared plus 1 is an imaginary root of this function right here, and we did get a 0 right here. So our remainder is 0, and x squared plus 1 has been proven to be a root as well. Okay, so now that x squared plus 1 has been proven as a root, what does it actually equal to? So like x is equal to 3 right here, and x is equal to -2 right here. X squared plus 1. And if we set it equal to 0, what is the actual root? So that will be x squared is equal to -1. So x is equal to the positive and the negative square root of -1, or as we know, the square root of -1 is just positive or negative I. So that is our actual imaginary root. And now let's get straight into the graphing. So to graph this function, we can't actually exactly graph it because we haven't been taught how to do that. So for like to find the extrema, increasing interval, decreasing interval, and the range, I'll probably use my calculator to make the points exact. But the end behavior and the domain and the roots we're gonna be using, or the points on the x-intercepts or the zeros, are we can do that by hand. So to do that, first we graph our roots. So it's gonna be at 3 right here and -2 right here. And since they have a multiplicity of 1, our lines will go straight through them like that. We also know that the highest degree on this polynomial is the 4th degree, meaning it's an even degree. And the leading coefficient of the 4th degree term right here is a positive term, meaning the end behavior, or the arrows at the end, are going to look like the positive. So this is x squared, so they're going to look like the positive version of an even graph. So the lines are going to go straight through right here, and both are going to be facing upwards. Now we also know that the y-intercept is a -6. So we can graph that right here. 1, 2, 3, 4, 5, 6. And now that's the graph we can say we have, because we can't actually graph the imaginary roots. So we can say the graph looks like this, and there are multiple ways to like graph this, because we don't know how to accurately graph the imaginary roots. So to do the domain, that's very easy. It's gonna be -infinity to +infinity, because the graph keeps going left infinitely, like to the left like forever, and to the right forever. So that's easy. Now the range, we actually don't know what's the lowest value, but we do know the highest value. So that's gonna be at infinity, which is the highest value because it keeps going up, but we do not know the lowest value. The end behavior is the one thing that we can say for sure that we know. So the end behavior is x, as x reaches -infinity, f of x reaches, let's see, positive infinity. And as x reaches positive infinity, f of x reaches positive infinity as well. Now to do the extrema and the increasing interval and decreasing interval, we're going to have to use, and the range, like the lowest point of the range, we're going to have to use a calculator. And I'm just going to quickly, let's see, let me quickly just get my calculator, and now that we have our calculator, I'm gonna type it all in, and I'm gonna press draw, and then I'm gonna solve for the extremas. So first, the maximums. So this is there are several extremas, so I'm just gonna do the absolute extremas, in which there is only gonna be one, which is gonna be the minimum. So let's see, so the minimum is gonna be at the point 2, 20.037, comma, negative 20.018. Now we know, since this is the lowest it goes, that's where our range starts from. So, bam, negative 20.018. Now our increasing intervals go from, let's see, from the extrema all the way to infinity. So negative 20.018 to infinity. And on my calculator, I do see that there's another point which is increasing briefly, and it starts from the point negative 1, 2, which is included, and this is included as well, negative 1.18, and goes to, let's see, okay, and goes to the maximum, not the maximum, and goes to the point negative 0.103. And these are all approximations. These are not the whole numbers. And now our decreasing interval, there are 2 of these as well. So it goes from negative infinity, which is not included, to negative 1.18, which is included. And then it goes from negative 0.103 to negative 20.018, both of which are included. So now that we have graphed them, let's verify our roots by multiplication. So to do that, we write our roots down, or the things we factored out. So we get x squared plus 1, x minus 3, and x plus 2. So that should equal the original polynomial right here. So let's see. First, let's multiply these 2 terms right here. So we get x squared minus 3x plus 2x minus 6. So that gives us x squared minus x minus 6 as our term, and then we bring down the x squared plus 1. Now we distribute x squared into each and every value here. So we get x to the 4th minus x to the 3rd minus 6x squared. Now we distribute the 1 and we get plus x squared minus x minus 6. So when we combine like terms, we get x to the 4th minus x to the 3rd minus 5x squared minus x minus 6. And this is the same as this right here. And that's all for day 2.